Today we're going to be talking about rational functions and simplifying rational expressions. So this is a really big concept. A rational expression is an expression that can be written in the form of P over Q, where P and Q are polynomials, and Q cannot equal 0, because you can never have 0 in the denominator because it's undefined. So the polynomial that Q polynomial cannot equal 0. So a rational expression is an expression that can be written in the form of P over Q where we're polynomial. So we're looking at something like x plus 3 over 2x plus 5, something like that. That would be a rational expression where we have two polynomials, and it could be trinomials and so on. Find the domain of each rational function. So find the domain of each rational function. The domain is the x values. Remember how we mentioned before about x values for the domain. So what we want to think about when we're trying to figure out the domain is if we were to graph this or visualize this rational expression or rational function, where would it exist on the x-axis? So meaning if I had like a graph here, and I'm going to erase this, but if I had like a x and y-axis and I had a line, we would think of that line existing from negative infinity to infinity along the x value. Because if I'm at x equals negative 100, I have a y value. If I'm at x equals 15, I have a y value. If I'm at x equals 50, I have a y value, and so on. So we have that image of, well, it exists everywhere. So that's what we're thinking about is, are there any spots where this graph does not exist? That's what we're trying to figure out. So what we have to keep in mind here is that the denominator, we cannot equal 0 because dividing by 0 would be undefined. So that's one thing we want to keep in mind. The denominator cannot equal 0 because then that would be undefined. The denominator cannot equal 0. That would be undefined. So looking at letter A, we have 7x minus 5 over 6. I don't really care what's happening in the numerator when I'm trying to define the domain. All I'm really looking at is the denominator, and that's just a constant of a 6. So I don't have any potential restrictions there, so it's going to be all real numbers. And I could write that as negative infinity through infinity. So for every x value, it's going to exist. It's completely fine. Letter B, 6x over 8 minus x. So 8 minus x, we have an x value there. That means that there is an x value, potential x value that we could find that would cause the denominator to make it equal to 0. So let's take the denominator, set it equal to 0. So 8 minus x equal to 0. I'm going to subtract 8. We get negative x equals negative 8. Divide by negative 1. And I get x equals positive 8. So that means when x is equal to 8, we will get 0 in the denominator. If we look at that, 8 minus 8, that's equal to 0. We cannot equal 8 because then we are dividing by 0, and we cannot divide by 0. So a potential issue in the domain is that when x is equal to 8. So our domain is going to be from negative infinity up to 8 unioned with 8 to infinity. So it exists everywhere besides at 8, because when 8 is in the denominator, we get 8 in the denominator, we get 0. We cannot divide by 0. And same thing I said before, we really don't care about what's happening in the numerator unless we could do some sort of like simplifying or something like that. But it's not really going to affect the domain. We really are focusing in on the denominator. We cannot equal 0 in the denominator. Take out letter C. 7 plus 3x over x to the third plus 2x squared minus 8x. So first of all, I could factor out a GCF of x. See how I have x's all across there? So I'm going to factor out an x. And I'm going to be pretty quick about the factoring in this video since the lesson here isn't necessarily factoring. And that's going to be x squared plus 2x minus 8. So to figure out what values would cause the issues in the denominator, we want to factor still. So this is going to be x. Two numbers that multiply to negative 8 add up to positive 2. That's going to be x plus 4 and x minus 2. 4 times negative 2 is negative 8. 4 plus negative 2 is positive 2. So these are my three terms that are going to be on the bottom, meaning I have three potential x values that could cause this to be 0. Think about it. If this is just 0, that's 0 times everything else. So it'll be 0 times everything else. That's 0. If this value here is -4, -4 plus 4 is 0. So we want to set all three terms equal to 0. And you can do this mentally too. You don't necessarily, I'm getting a little close to my camera. X plus 4 equal to 0, x minus 2 equal to 0. Like you don't necessarily have to write it all out because you could do some of that mentally. So then we have x equal to 0, x equal to -4, and x equal to 2. So x cannot equal 0, x cannot equal -4, and x cannot equal 2. Because if it equal to any of those three values, we will get 0 in our denominator, which is undefined because we're divided by 0. So we can write it out in interval notation if you want. There's sometimes you can just write like all reals except at x not equal to 0, x not equal to -4, and so on. But I'll just keep it consistent with, I'm going to write it in interval notation. So the interval notation here is we're going to go from -infinity to -4. That's my first value. Unioned with, then I'm going to go from -4 to 0. Union. Then I'm going to go from 0 to 2. Union. And I know I'm right on top of my camera. From 2 to infinity. So there is my domain. It exists everywhere besides when x equal to 0, x equal to -4, x equal to +2. So that's finding the domain of a rational function. Simplifying a rational expression works a lot like simplifying a fraction. If you have the number, let's say we have like 12 over 16. If I'm simplifying 12 over 16, what I want to think about is I want to think about a GCF, meaning what goes into both 12 and 16, that largest possible number, and that's 4. So I'd have 4 times 3 and 4 times 4. So what we can then do is simplify the 4s. 4 over 4 cancels out, so we're just left with 3 over 4. Simplifying a rational expression works the exact same way. Let's go ahead and take a look at that. So number 2a, I have 3x minus 1 over 18x squared minus 6x. I threw in an 18 there after I worked it out. I'm like, wait, that doesn't really work out nicely, so I threw in an 18 there. But we want to factor, so the top does not factor, so 3x minus 1. The bottom, 18x squared minus 6x, what could I factor out from there? I could take out a GCF of 6, because 6 goes into 6, 6 goes into 18, and x. So I'm going to take out 6x. That's going to leave me with 3x minus 1, because 6x divided by 6x is 1. Then look what happens. See these factors of 3x minus 1? The both top and bottom have a factor of 3x minus 1. Those are going to cancel out. And now, what am I left with on top? I don't have anything left on top, so that's just going to be 1 over, and then I'm left with that 6x on the bottom. So a common error here is people will, simplify and then just write 6x. They'll see like, oh, I'm just left with 6x, that's it. But 6x is in the denominator, so you have to make sure it's in the denominator. You can't just like throw it in the numerator. It's in the denominator. So 3x minus 1's cancel out, leaving us with 1 over 6x. So we got letter B. So letter B is interesting because it says x plus 8 over 8 plus x. Those are equivalent statements. X plus 8 and 8 plus x are the exact same thing. So these two factors of 8 plus x and x plus 8, those are the same thing. Those are going to cancel out. So we're just left with 1. So that answer is just 1. 8 plus x and x plus 8 simplify to 1. And then letter C, 9 minus x over x minus 9. So what can we do here? 9 minus x over x minus 9. Those aren't quite the same, because this is a positive 9, this is a negative 9. This is a negative x, this is a positive x. So those aren't quite the same. So what can we do to get around that? Well, there are complete opposites of one another. 9 and negative 9, negative x and x, those are complete opposites. So we could actually just factor out a negative 1 from the top. So let's factor out a negative 1 from the top. Negative x, so I'm looking right here, negative x is going to become positive x. A positive 9 is going to become negative 9. And that's over x minus 9. Now what happens? X minus 9 over x minus 9 cancel out, leaving us with negative 1. So you got to be able to manipulate it a little bit and understand, like, well, if I do this to this, then this is what's going to happen. Try to predict what's going to, or try to see ahead a couple steps. Like being able to manage that, like, well, these are complete opposites of one another. So therefore, if I take out a negative 1, then I'll create the same thing, because then the opposites will turn to the same. Because you take the opposite when you're factoring out a negative 1. So being able to see that is a little bit of a challenge at first. Let's keep going. So letter D. 4 over 8x minus 24. So what could we do here? Well, the 4 I could leave alone. But on bottom, I can factor out an 8. So I'm going to take out 8, because 8 goes into 8, 8 goes into 24. So that's going to leave me with x minus 24 divided by 8 is 3. Four over 8 can simplify down. So 4 over 8. 4 goes into 4 one time. 4 goes into 8 two times. So that's going to be 1 over 2 times x minus 3. Next one, x plus 2 over x squared minus 7x minus 18. So what can we take care of here? Well, I can, first of all, factor the denominator. So x plus 2 is going to be left alone in the numerator. The denominator can factor two numbers that multiply to negative 18 and add up to negative 7 is going to be x minus 9 and x plus 2. So negative 9 times 2 is negative 18. Negative 9 plus 2 is negative 7. And then what generates from there is the fact that we can now simplify x plus 2's. Those are going to cancel. What am I left with on top? Everything canceled besides that x minus 9 in the denominator. So what am I left with on top? Just a 1. You got to have a placeholder of a 1 over x minus 9. On the letter F, x to the third plus 10x squared. I could factor out a GCF of x squared from there. So what am I left with? I'm left with x plus 10. In the denominator, two numbers that multiply to negative 20 add up to positive 8. That's going to be x plus 10 and x minus 2, right? 10 times negative 2 is negative 20. 10 plus negative 2 is positive 8. So from here, what happens? I have an x plus 10 over x plus 10. Those are going to cancel out. Nothing else I can cancel out, so I'm left with x squared over x minus 2. Common mistake here. This is our answer, but the common mistake is sometimes new to this topic, you'll see like, oh, I have x squared over x. Like you'll be looking at this x squared over x and think x squared over x is going to simplify down to x, because when you divide by the same base, you subtract the exponents. But that's not what's happening. Think of it as if x was equal to a number, like x is equal to 1 or 2 or whatever. This term on top, if I said, don't write this down or anything, but if I said x equal to 1, this would be 1 squared. And then 1 minus 2, so this would be 1 over negative 1. So it's not working where it's like, oh, well, 1 and 1. Those are not factors. That's just an expression. But if I say x is equal to some value, then it's going to change things around. So if I had like x over x plus 1, something like that, like the x's wouldn't cancel there. That's not how that works. Because x would equal something like 2, so it'd be 2 over 2 plus 1. It's like taking this number here is like taking 3 and separating it into 2 plus 1. So I'm not able to just say, like, if I had like 4 over 2 plus 1 like that, like I wouldn't do 4 over 2 would simplify down to 2. I would say 4 over 3. So just understanding how that works is a little bit tough at first. All right, let's move on to some more simplifying. So here we have 2x squared plus 7x plus 6 over 2x plus 3. So the factoring here is, I don't have a GCF that I can factor out, so I have to use AC method. So I'm going to do 2 times 6 is 12. So two numbers that multiply to 12 add up to 7 is going to be 4 and 3. So I'm going to be pretty quick about factoring here, since the lesson here is not factoring, it's simplifying. So 2x squared plus 4x plus 3x, because this is going to be 4 and 3, plus 6. And then we got a group. So I'm going to group these two, group those two. So I'm going to factor out a 2x, left with x plus 2. Factor out a 3, x plus 2. And then look at that, we got our x plus 2's. And left with 2x plus 3. Okay, so factoring the top was x plus 2 and 2x plus 3. All over 2x plus 3. I can then simplify 2x plus 3's. Simplify those out. And I'm left with x plus 2. Done. 2x plus 3s were factors, and they simplified. Let's check out letter B. 4x squared minus 64 over 16x minus 6. So from 4x squared minus 64, what could I factor out there? Well, 4 goes into 4, 4 goes into 64. So I'm going to take out a 4, but look what happens when I do that. So I'm going to take out a 4, I get x squared minus 16. And then I'm going to factor the bottom while I'm at it. I'm not done factoring the top. But on bottom, 16x minus 6, I could take out a 2. So that's going to be 2. And then 16x divided by 2 is 8x. 6 divided by 2 is 3. Now in this problem, it didn't really do anything for us, but I could actually factor the numerator one more time, x squared minus 16. That's the difference of two squares. So that's going to be 4 times x minus 4, x plus 4, over 2 times 8x minus 3. And then we could just only simplify the 4 and 2. So that's just going to be 2. 4 divided by 2 is 2. So 2 times x minus 4 times x plus 4. Typically, there would be some sort of cancellation that could happen from that, but in this problem, we didn't have that. So it's just maybe not a correctly written problem, but sometimes there'll be like a simplification that can be made there. But in this case, there's not. So we'll just leave that alone as is. Just something to look out for, though. Just because you're factoring out the GCF, we then create a difference of two squares, so we got to factor that completely. Let's look at letter C. X squared plus xy plus 9x plus 9y. So we can factor by grouping here. So from the first set of parentheses, I could take out an x, left with x plus y. From the second set of parentheses, I could take out a 9, and that's going to leave me with x plus y. Over x plus 9. And then we're not done factoring the top, though, because this is factored by grouping. So we just grouped. We factor out the GCF. Now we could factor out the x plus y. So I'm going to take out x plus y and x plus 9. And then I'm left with x plus 9. So we have x plus 9 is canceling, leaving me with x plus y. Letter D, x to the third plus 27 over x plus 3. So on the top, we have x to the third being a perfect cube, 27 being a perfect cube. So we have a sum of 2 cubes. So this is going to factor to x plus 3, just knowing your sum of 2 cubes formula. And then that's x squared minus, and this is, remember, this is 3 to the third. It was just 27. This is x to the third. So this is going to be 3x plus 3 squared is 9. And that's just knowing your sum of 2 cubes formula over x plus 3. X plus 3's cancel out, leaving us with x squared minus 3x plus 9. Sum of 2 cubes. So you got to know your factoring there. Sum of 2 cubes. All right, last scenario here is just looking at some application to what we've been kind of talking about. The total revenue for a popular board game is approximated by the rational function r of x equals 1600 x squared over x squared plus 4, where x is the number of years since release, and r of x is the total revenue. So part A, find the total revenue at the end of the first year. So this function represents x in the number of years, and then the total revenue is represented by that function. So if we want to know the first year, that's going to be x equal to 1. So we're going to take r of 1 and do 1600 1 squared over 1 squared plus 4. I'm just going to go to my calculator. 1600 times 1 squared is 1600 divided by 1 squared is 1. 1 plus 4 is 5. So divide by 5, which is 320. Part B, find the total revenue at the end of the second year. So that's going to be x equal to 2. So we're going to do r of 2. So 1600 2 squared over 2 squared plus 4. So I'll just go to my calculator here. 1600 times 2 squared divided by 2 squared is 4. 4 plus 4 is 8, so divide by 8, which is 800. Part C, find the revenue during the second year only. So this function represents the number of years since release. So part B says after the second year, which is 800. So I think this is supposed to be millions or something, or thousands. I don't know. It doesn't say. Yeah, it doesn't say. So at the end of the second year, they have 800, but that's including the first year. So what is it for the second year only? Well, we have to take year 1 and subtract it from year 2. So we're going to do 800 minus 320, which is going to be 480. So in the second year only, they made 480. Then find the domain of function R. So the domain is all the x values. So if we look at our denominator, x squared plus 4, this can be any number because it's the x value is being squared. So if x is equal to like -10, it's going to become positive, or x is equal to -1, it's going to become positive. But we're talking about a real life scenario here where x is the number of years since release. So think about the logic here when talking about the domain. Can x be negative at all if we're talking about x is the number of years since release? No, it cannot be negative. So the domain is x has to be greater than or equal to 0. It cannot be negative because we cannot be talking about negative years since release. It doesn't make sense. So the x values have to be positive, greater than or equal to 0. So every number greater than or equal to 0 there. Yeah, so that was a little bit of an application there to simplifying rational expressions.